Hello, in this section of the tutorial we're going to cover the topics of basically how to use the graphing function in your calculator to calculate the definite integral of a function. And so if you don't know what a definite integral is, why don't you just watch this anyway, and you'll probably learn a little calculus here. It'll be really easy for you. I promise you will understand it. And if you do know what a definite integral is and you're taking calculus, then this will be a really neat function that you can use in your calculator to help you out. First, we need to graph a function. So let's go ahead and pick something. I'm kind of tired of looking at that one. So let's pick something different. Let's go x cubed minus x, let's say, plus 2. X cubed minus x plus 2. And let's go to the standard zoom. So that's number 6. And it's going to plot this for us, so it's a nice little function. Now let's go ahead and zoom in a little bit onto the interesting area, Z-box, and let's go ahead up here and do that because I just want to, we can just do it here, but I think it's just more interesting if we just zoom in on the interesting portion of the graph. That's why I picked this graph, because it has a nice little curve associated with it. We'll go down and let's do something like that. We'll hit enter. And the graph is redrawn. It's nice and beautiful, and here it is. Now, what we want to do is we want to find the definite integral. And just as a quick review, what an integral is it's basically a way for you to use calculus to calculate the area, the surface area underneath this curve, between the line here, the curve that we have, between this and the x-axis. So it's really no different than in 5th or 6th grade when you learn how to take the area of a rectangle. That was basically a method that you learned to calculate the area of a rectangle or a circle or whatever by using a formula. Well, obviously this curve is a little more complicated than a circle or a square, so there's not a real easy way to do it with a simple equation. You have to use calculus if you want to find the area of this function between this function and the axis here. So you can use the tools of calculus, find the integral and evaluate it, and you get the answer, and the answer you get back is going to be, square meters, or so many, if this function is defined in terms of meters, or square centimeters or something, which would be the area